Hey everyone, in this video and the following videos, we're going to be looking at how we solve system of equations. So what exactly does this mean? You might be wondering. A system of equations, and what is a system? What does it mean to solve it? To solve a system of equations, first of all, we have to be given two equations. We look for the point, so the point xy that satisfies, keyword satisfies, both equations. Okay, so this word satisfies, what does that mean to satisfy an equation? So I can tell you, just an example here, the point -2, 3, it satisfies the following equation. So the equation is 3x plus y equals -3. So I tell you that this point satisfies this equation, and what that means is when I place x and y into this equation, this left side will equal the right side. So when I place -2 in, so 3, place -2 in for x, and place 3 in for y. Okay, so -6 plus 3. -6 plus 3 is -3. And we see that the two sides equal each other. So when a point satisfies an equation, that will happen. So if I were to plug in, 0, 3, and place those values in, it would not satisfy it because what I get on the left side would not equal what's on the right side. Okay, so to satisfy an equation just means that when placed in, both sides of the equation are the same, are equal to each other. So to solve a system, we look for one point that satisfies two equations, and you'll have these two equations given to you. And there are different methods of solving these problems. So to begin with, let's look at, there are three different possibilities. So these here, there are three possible situations. There are three possible situations when solving a system of equations. I did not even think about this. This word system is referring to a group of equations. So when I solve a system of equations, I'm finding a point that fits a group of equations. And at the beginning here, we're just dealing with two equations again. So our three possibilities are standard form, where both of them are in standard form. So recall standard form is when both our x and y are on the same side, whether left or right, they're on the same side. So then the other situation is when one equation's in standard form, and the other is either y equals or x equals. So that's another situation that will require a completely different process to solve than this first situation. And then we have both, when both equations are in y equals form. So I have examples here. So as we're doing these problems, I encourage you to write these down, to have paper, whether it be graph paper or just your notebook paper, to write these examples down, to pause the video at any point, rewind at any point you need to, but really utilize this video to understand how we solve systems with the various situations, okay? In this lesson, we're going to be focusing on this situation where both are in y equals form. So how do you solve a system of equations? How do you find the point that satisfies both when they're written in y equals form? So we call it the graphing method, because essentially what we're going to be doing is graphing the two functions. And if you've seen this before, you know exactly what we're going to be looking for when we graph them. But if you haven't yet, well, you'll see in these examples. So the graphing method is the preferred method when both equations are in y equals. So let's examine this problem. Let's find a point that satisfies the following system. Y equals 2x plus 5 and y equals negative 3x minus 5. So obviously we're graphing, so we're going to need to create a coordinate plane. Okay. What I love about the graphing method is it requires us to practice our graphing skills. So when I go to graph this first equation, so we're going to call this first equation, let's use orange for this first equation. So when I graph an equation, my constant, my number here, we are going to say it is the starting number, the starting point. So I'm starting at 5. And we always start on the y-axis. Okay, so this is where we base our graph off of. So we start at 5, and then to get to my next point, we have a slope of 2, which really, it's not written here. This is 2 over 1. So slope says we rise 2, and we're going to run 1. Or we go up 2, and we go right 1. So up 2, right 1. Up 2, right 1. You notice I can't. So rather than going up and then right, I can get the same result as going down and left. But if I can go up and right to begin with, I want to do that because that's going to help me with the other side. So keep going, just get a little more coordinates here. One more time, down. Okay, so down 2 over 1, down 2 over 1. So with this, we can easily connect to make our line. Okay, so that's our first equation. Our second equation. So starting point of negative 5, 1, 2, 3, 4, 5. Notice negative 5 went down 5. And now we have a slope of negative 3, or negative 3 over 1. So we're moving our point down 3 and right 1. So I can go down 3 again, but I'm going off of our coordinate plane. So rather than going down and then right, I'm going to go up and then left. And notice I'm still in line with my points. I don't want to go up and then right because then I'm not in a line. So we just keep doing this. Up 3, left 1, up 3, left 1, up 3, left 1, and so on. So with these points, we can connect them. Okay, we have our graph. And to solve this system, if I'm able to graph the problems when they're in y equals form, the solution, this is what's amazing about this method, the solution is staring at us. Where the two lines intersect is the solution. So this coordinate is, write this down, this coordinate is negative 2, comma, positive 1, and that is the solution. So we want to, a little note here, we want to look for the intersection. Okay? Now this is the solution, meaning if I were to place negative 2 into x and 1 into y, that it would satisfy both equations. Okay? So you can do that on your own, just so you can practice that, but trusting our graphing skills, it should be the solution. So let's look at another example. I have a couple of examples here for us to look at with this graphing method. So let's say we want to solve this system. So right now you can pause it, get everything written down. And we see that when we graph it, let's again use orange for this first one. What's our starting point in this first equation? That should be -1. And our slope is 1/4, which would say we rise 1, we go up 1, and then go right 4. Right 1, sorry, up 1, right 4, up 1, right 4, and so on. If I wanted to go the other direction, go down 1, left 4. Just make sure I'm in line still. So we can connect these and we get our equation. All right, so let's graph this other one. So looking at this next one, starting value, there's nothing there, which would say that our starting value is 0. So starting value is 0, or we have a slope of -3, so that this is -3/1. So we go down 3, right 1. Down 3, right 1. We go up 3, left 1, just get more points. And we see the intersection. Okay, so you see that we know where the intersection is, but we aren't exactly sure, so it's unclear where this intersection is located. So this is graphing. This is one downside to the graphing method. We can graph, yes, but when our intersection's not at a nice clear point, it can make it difficult to find a solution. So we have at our disposal these graphing calculators of different types. I have the TI-84 plus C. So we turn this on. Oh, look at that. Huh. So we go to y equals. Let's clear this out. We go to y equals. In the first row, we type our equation in. So y equals, we do parentheses 1/4, 1 divided by 4x, and we subtract 1, and we do -3x, and I can put +0 if I want to, or it's not needed. So I have that. Now, because your calculators are most likely used by other people, if you're in school and using the school's calculator, it is always good, rather than hitting just graph, it is always good to hit zoom. Zoom's in the middle up top. To hit zoom, and then we want standard. So I can just actually hit 6. Done. I just hit 6. We zoom standard, and it does that for us. Hitting just graph right away, you might have had someone use the calculator and they changed the window. So hitting zoom and then 6 gives us just back to the default. Alright, so if we compare this to what we have, yeah, looks good. We graphed it right. So to find the intersection, I'll write this down. So to find the intersection with our graphing calculator, we hit second, and then we hit trace. We get this list. We want intersect. Okay, so intersect, that's going to be option 5, so I can just hit 5, and it's going to show up as the bottom, first curve. So I hit enter. After getting to intersect, I hit enter. I see first curve, enter. Second curve, enter. Guess, enter. And I will not have my answer. This is very important. I will not have my answer until I see intersection at the bottom. So you're going to go through first curve to second curve to guess, and then you're going to see intersection. All right, so I have to go through each of those to get my answer. So my answer, the solution to this system, according to our calculator, is 0.308 rounding, and then comma negative 0.923. So these are approximates. So this is an approximate solution, because I had to round. So if I were to place these back into my equation, the left and right side might be slightly off, only because we had to round off of our screen here. Okay. Using the graphing calculator is good. It's a good tool. Even if we can visibly see where the intersection is, this is a good tool to check our work. All right. So put this to the side again, and we have our last example. So let's solve this problem. So we're ending this video looking at this unique problem. You'll see how it's unique when we graph it. So y equals 1/3 x plus 2, y equals 1/3 x minus 4. So we graph this. Okay. We have this, so starting point of 2. Up 1, right 3. I'm just continuing that. And other direction. Okay. And using the green once more, starting point of -4, up 1, right 3. Okay, and we notice, this is a little odd, there is no intersection between the two. There's no intersection. That's a little strange. So what does this mean? So there's no intersection. What this means for us is that the two lines are parallel. You're thinking, well, yeah, look, we know from looking at the equations that when the slopes are the same, when the slopes of two lines are the same, they're never going to intersect, because their vertical and horizontal change, like they go up and over the same amount. So how could they ever actually intersect if they're moving the same way? So because the two lines are parallel, because there's no intersection, in terms of a solution, there is no solution to this problem, to this system. So no intersection, there's no solution. When the two lines are parallel, there's no solution. There is no x-y coordinate that would satisfy both equations. It might satisfy one, but not both when they're parallel. I wish you the best of luck going through the graphing method and when it's used and kind of the downsides of it. So I wish you the best of luck in practicing this skill, and I'll see you in the next video.